Hi everyone, welcome to another linear algebra tutorial. In this tutorial, I'll be talking more about matrix, giving a brief background about matrix before we go into details on how to describe solution sets of systems that have unique solution, infinitely many solutions, or no solutions at all. So let's first go into the basic properties of a matrix. So a matrix has a row and a column. So as you can see, these are the row and the column will be in this form. And the content inside these matrices are all arrays. So let's say if I were to find the array of row 1, column 1, our array of row 1 and column 1 will be 1. And the array of row 1, column 2 will be 3. So now let's find the indicated array of the matrix if it is defined. So this will be our first questions. So the first one will be the array of the matrix in the second row and first column. So hence it is 2. Why? Because we are array of the second row and the first column, which is here. So this is 2. So for the next one, what is the answer? It is definitely 3. Why? First row, array 1, and row. So we label according by row and column. So first row and then followed by the second column. First row and second column, which is 3. So now how about for the second row and second column? It's -1. Why? Second row, then second column. And the same goes for array of the third row and first column. Hence, but however, in this case, we only have matrix up to the 2 rows. It's up to the second row. We do not have a third row matrix. So hence, this is invalid. So it's not applicable. So now let's go into this. So how do we know the size of the matrix? First, let's take a look at this equation. As you can see, the size of the matrix is based on the rows and columns. So first, what is the size of this matrix? It has 2 rows and 3 columns. So we call this a 2 by 3 matrix or 2 times 3 matrix. So let's go into details to understand more. So these are our details. So give the size of each matrix. So first one, how many rows does it have? It has 2. And how many columns does it have? It has 3. So hence, this is a 2 by 3 matrix. How about for B? As you can see, it has 3 rows, 1, 2, 3, and 2 columns. So hence, it's a 3 by 2 matrix or 3 times 2 matrix. And for C, it has 2 rows and 2 columns. Hence, it's a 2 by 2 matrix. And now, let's take a look at some of the vector operation here. So now, we are given this. So we have already learned what is a scalar multiplication and addition of vectors. So now let's practice what we have learned. So for the first one is only a addition. So hence we add. As you can see, we add, and hence we get this. I guess this is pretty straightforward. And for next one is scalar multiplication. Scalar multiplication means, so for the 5, then 4 minus 1 will give me 20 minus 5, as you can see here. So I add the 5 times 4, and then I add 5 times 4, and then 5 times minus 1 is a scalar multiplication, so it's 20 minus 5. How about for C? For C is the same. It's just minus, so you just ensure that it has the same row and column, like both matrices have the same row and column. So hence you get 1 minus 3, 5 minus 1, 1 minus 1, you get minus 2, 4, and 0. And for 7, this involves scalar multiplication and a vector addition. So first, what do? We solve the scalar multiplication first, like what we learned in our basic equation. So multiply first the inside one, and this, you get this, and then you followed by this. After you do scalar multiplication, you get this and this. So you do addition of vectors. Look, it has both matrices have 2 rows and 1 column each. So you add, and hence you get this. Now, how about the last one, which is this? Notice that the 2 matrices have different rows but the same columns. Hence, we are not able to apply the vector operation. Hence, it's not defined, and the reasons are here. 2 matrices need to have the same number of rows and columns in order for us to do vector operation. And usually, in this case, we want to do vector addition. We cannot add in because it has different rows. So hence, it's not applicable. So for our next tutorial, we will learn how to describe the solution sets or systems using vectors, vector notations.